Complex. Professor Deb here. In this video lecture, we'll be talking about the operations with complex numbers. This is one video in a series that work with complex numbers. This particular video is one of two regarding the operations. So this video will work with the operations of addition, subtraction, and multiplication. And the other video that is on operations will deal with division and raising to a power. So, ready to get started? Here we are, addition and subtraction. Remember when displaying a complex number, it is a plus bj, and that again is the rectangular format. So when we're adding and subtracting, we're doing that with rectangular format. You cannot do addition and subtraction of the polar format or the exponential format that was described in an earlier video. If you need to add or subtract the polar or the exponential, you must first change it to the rectangular format in order to do that. We'll be using all of the formats with multiplication and division and raising to a power. But for the addition and subtraction, just the rectangular formats. Let's get started. To add two rectangular, here we go, to add two rectangular numbers, what we do is take the first number, which would designate the A, and we put them together. And then what we're going to do is we're going to put together the J's. So we're going to have 21 minus 7 plus 3j minus 6j. And that makes it a lot simpler. Okay, 21 minus 7, of course, is 14. And 3j minus 6j, we could have left that out and put minus 3j. So that is our answer to adding these two complex numbers. Now we're going to do the same thing with subtraction. However, you remember that when you have a subtraction sign in with parentheses following, that you distribute that subtraction or negative sign inside the parentheses. So for clarity, let's rewrite it. Let's step it out. And we'll change it to addition. And we'll distribute that negative in there. And now we do just like an addition problem, right? Okay, so we'll combine the two A values and we'll combine the two J values. And 14 minus 6 is 8 plus 2j. So there is our answer for subtracting these two complex numbers. Let's look at another one. We're going to do the same. This is just another example. So we combine the A values and we combine the j values. So we have our answer as 1 minus 7j. That is our answer. Okay, now, here we've got a little more complicated, and we're going to go back to those earlier skills when we had that negative sign inside the radical and we were working with that. Now we know what to do with that. We bring the negative sign out as j, right? And then we take the square root of 25. So let's rewrite this to make it a lot simpler for us. That would be j 5. All right, tell you what, let's rewrite it in correct nomenclature. 5j minus 3. Now remember, we're going to distribute this in -3, and that negative changes the sign to a plus, and we bring that out as 5j. Okay, now we should be able to do this. We're going to combine the a's and combine the j's. I'm going to skip a couple steps and go right to it. There we are. -6 plus 10j. That is our answer. All right, here are two for you to try. Stop the video, try these, and then check your answers on the website. Ready to go to multiplication? Hope you did well on the addition and subtraction problems. Let's go to multiplication. Now we see here when multiplying two polynomials. What did we do when we multiplied two polynomials? Well, if you've seen some of my videos before, I'm going to use this little nomenclature idea that I always work with, and you're going to laugh. That's called smiley faces. So there's my first smiley face, and I've got -2j times 7j gives me -14j. And my second smiley face, -3j times 4 is -12j. I come down and I add those together. I get -26j. That's my middle term. Now many of you may be familiar with FOIL. This is the same thing, only I think it's nice to use smiley faces. Here's my first eyebrow. 4 times 7. That's 28. And my second eyebrow, -2 times a -3 is a +6. I've lost my... There we go. I'm sorry, I didn't want that. I wanted negative. I lost my pen there for a little bit. +6j squared, and I could have wrote that a little bit nicer. I'm sorry. So again, a -3 times -2 is a +6, and don't forget we've got j times j. Now from the earlier videos, what does j squared equal? Do you remember? J squared equals -1, right? So now we have 28 minus 26j, and that would be 6 times -1 equals -6. Now I combine my A values, and I end up with 22 minus 26J, and that is my proper rectangular format. Alright, you want to try multiplying in polar format? All we're going to do is we have two complex numbers in polar format, and in this case I've used the long format with cosine and J sine. And what we're going to do is take the r's and multiply them together, and we're going to take the thetas and add them. So let's pick up our r's. That's 4 and 5. So we've got 4 times 5. And I'm going to put this back into CIS format, just for sake of getting through this video in less time. CIS, and what do we have? 135 plus 63. So we've got 20 CIS, and 135 plus 63 should be 198. Now I should be using my degree symbol here. Okay, 20 CIS, 198. Now it's very simple to use the CIS and get that set up correctly, but we could have written it in the original format that it came in. CIS 198 plus, let's put that degree symbol in there. There we are. So there's your polar format. Now let's see what happens with exponential. We take the r's and we multiply them together. We have the E designating exponential, and again we take the thetas and we add them together. So here we are with a problem. We'll take 3 times 4. We'll keep our E, and this actually is a 1J, so I'm going to put a 1J just for clarity, plus, remember in the exponential formats these are given in radians. So what we end up with is 12 E to the 3J. Alright? So, rectangular format, we like to use our smiley faces, right? And polar format, and exponential format. That's how you multiply in all those 3 formats. Want to try another one first? Alright. Bringing back those skills of what to do with the negative sign underneath the radical. Alright, so let's rewrite this first. We know that a negative sign comes out of the radical as J. So we have 2 times 3J plus 3 and our second one is 5 times 4J minus 2. I better go a little neater here, I'm running out of the line. Okay, so let's rewrite this. 6J plus 3 4J 45j minus 2. Oops, I'm sorry. That's a 4. I can't read my own writing. We're in trouble. Okay, so 5 times 4 is 20j. So that's a little bit easier to work with too, isn't it? All right, we're back at the beginning where we were on the other slide. Okay, smiley faces, I love it. 60j. My other smiley face gives me negative 12j. And 60 minus 12 gives me 48j. Okay. My first eyebrow, 6j times 20j. Is 120j squared. Don't forget that j squared again. And my second eyebrow is 3 times negative 2, which is minus 6. Now we know that j squared turns into a negative 120. So we'll put the a values together. Negative 126 plus 48j. Okay, so we've used all our skills, taking the negative sign out of the radical, and then we've multiplied the rectangular format. Let's try the polar format again. Okay, we're going to take the r's and multiply them together. So I've got 6.4. Those 4's look a little bad, don't they? A little shaky tonight. 6.4 times 3.5, and I'm going to use that CIS and then rewrite it in the end. These are in radian format, which is no problem. You can use radian format or degree format. So we've got 6.4 times 3.5, and that's going to equal 22.4. And we'll keep our CIS, and adding those together should be 1.35 radians. So I can write that in the original format, 22.4, where'd my point go? There it is. Cosine 1.35 plus j sine 1.35. All right, that's our second example with multiplying two polar complex numbers. Let's finish up with one more example of exponential, multiplying exponential. So 3.6, we take the r values, 3.6 times 2.5, and that's e. And now we're going to add the radians. Okay, let's see what we've got. 3.6 times 2.5, that's easy, 9. And that gives us e to the 11.5j. Okay, that's a little confusing. Let's look at something again. Remember that radians are degrees on a circle. And at this point, we have 0 degrees or 360. We also, in radians, have 0 or 2 pi. And that 2 pi is equal to 6.28. Now, if we've gone 11.5 radians, that means we've already gone all the way around the circle and then some. Well, we don't want to specify our ending exponential format with 2 revolutions. So what we need to do is take that 11.5 and subtract 6.28, and we get 5.22. So that way we're only going around the circle 1 time. So let's re-specify our answer now. 9e to the 5.22j. That's the proper way to specify it. So anytime you go over 6.28, remember to subtract the single revolution of 6.28 in order to get only 1 revolution. All right, we've gone through 2 examples of multiplication in the rectangular, the polar, and the exponential format. Here's 3 for you to try. Stop the video, work on these, and then check the website for the solutions. Hope you've enjoyed this video. Signing off.